The Su-57 project began with high ambitions to produce Russia's first true fifth-generation fighter, designed to compete with the advanced American F-22 and F-35 jets, as well as China's J-20. The program was intended to deliver an aircraft that combined stealth, supermaneuverability, advanced sensors, and multi-role capability, capable of dominating future air combat scenarios. However, more than 2 decades since its inception, the Su-57 remains far from fulfilling those promises. In fact, the program is widely considered a failure in several critical areas, and the aircraft is not seen as a credible fifth-generation fighter by many independent analysts and experts. One of the primary problems with the Su-57 lies in its production and delivery timeline. Initially expected to be fielded in large numbers by the early 2020s, Russia has only managed to build and deliver around 20 to 30 aircraft, including prototypes, test models, and limited production jets, as of 2025. This number is minuscule compared to the hundreds of fifth-generation fighters produced by the United States and China over the same period. The limited output stems largely from the complexity of the program combined with the impact of international sanctions. Sanctions have severely restricted Russia's access to high-tech components necessary for the aircraft's sophisticated avionics, engines, and stealth materials. Components like AESA radar modules, advanced microchips, power supplies, and composite materials are either unavailable or have to be sourced through black markets or third countries, which slows production and drives costs up. Even when aircraft are produced, the quality issues that plague the program raise serious questions about its combat effectiveness. Observers at recent airshows and from leaked images have highlighted glaring manufacturing flaws, including visible screws and bolts on surfaces that should be smooth and seamless, uneven panel gaps, and inconsistent coatings. These defects not only undermine the aircraft's stealth capabilities but also suggest poor manufacturing standards and rushed assembly. Stealth fighters rely heavily on their shape, coatings, and flawless surface treatments to minimize radar detection. Exposed fasteners and poorly aligned panels increase radar reflections and can make the aircraft detectable at much greater distances. Independent estimates place the Su-57's radar cross-section closer to that of a fourth-generation fighter rather than a true fifth-generation stealth jet, which severely limits its survivability in contested airspace. The aircraft's stealth design also suffers from fundamental engineering compromises. Unlike the F-22 and F-35, the Su-57's engine nozzles remain open and exposed rather than being shielded or shaped to reduce infrared and radar signatures. Its air intakes lack the serpentine ducts used in other stealth fighters to block radar waves from reaching the engine blades. These design decisions are believed to have been made to improve maneuverability and speed but come at the expense of stealth, raising questions about whether the Su-57 can realistically operate undetected in modern integrated air defense environments. The engine remains one of the program's biggest weaknesses. The aircraft was supposed to be powered by the new Izdaliye-30 engine, which promises better thrust, improved fuel efficiency, supercruise capability, and reduced infrared signature. However, this engine is still in limited production and testing phases. Most Su-57s, in service today, use the older AL-41F1 engine, originally developed for the Su-35, which does not offer the full capabilities envisioned for the aircraft. Without widespread deployment of the Izdaliye-30 engine, the Su-57 cannot consistently achieve the performance levels required of a modern fifth-generation fighter. Retrofitting older airframes with the new engines is complicated and unlikely to happen on a large scale anytime soon, limiting fleet-wide performance improvements. Avionics and sensor systems, essential for modern air combat, also lag behind Western and even Chinese counterparts. Russia claims that the Su-57 is equipped with the N-036 Bilka AESA radar and advanced electronic warfare suites. However, technical analysis reveals that its radar has fewer transmit-receive modules compared to the F-22 and F-35 radars, which impacts detection range and tracking precision. The aircraft's sensor fusion capabilities, integrating data from radar, infrared sensors, and electronic warfare systems into a unified display for the pilot, are also reportedly less advanced. This reduces pilot situational awareness, a critical advantage in modern aerial combat. Sanctions on advanced semiconductors and electronic components have hindered Russia's ability to manufacture reliable avionics, resulting in frequent delays and reduced functionality. The operational record of the Su-57 has been equally unimpressive. Since its limited deployment in Syria starting in 2018, the aircraft has not been used in any high-intensity air-to-air combat. During the ongoing conflict in Ukraine, it has primarily been used to launch long-range missiles from Russian airspace, far from contested air defense zones. This cautious use highlights the aircraft's scarcity and Russia's reluctance to risk losing what few Su-57s it has. In June 2024, a Su-57 at the Aktubinsk airbase was reportedly damaged by a drone strike, a rare instance that underscores the vulnerability and limited operational deployment of the jet. The lack of combat experience makes it difficult to assess the aircraft's true capabilities but also suggests it has not yet earned a place as a frontline asset. Export prospects for the Su-57 are bleak. India, once a partner in the FGFA program based on the Su-57, withdrew from the project in 2018 due to dissatisfaction with the aircraft's performance, stealth characteristics, and development delays. Since then, Russia has struggled to find buyers. Algeria remains the only confirmed foreign customer, having placed a small order for the Su-57E export version. However, deliveries have been slow, and the aircraft has yet to see operational use in any foreign air force. Many potential buyers are reportedly wary of the aircraft's unproven combat record, sanctions-related maintenance challenges, and uncertain future upgrades. The combination of slow and limited production, ongoing technical and quality issues, reliance on outdated engines, compromised stealth design, and lack of operational deployment paints a clear picture of a project that has failed to meet expectations. The Su-57 is unlikely to change the balance of airpower anytime soon, and it remains a symbol of Russia's struggle to modernize its military aerospace industry under difficult economic and geopolitical conditions. Despite official statements portraying it as a cutting-edge fighter, the reality is that the Su-57 program has fallen far behind the capabilities, production scale, and global influence of its Western and Chinese rivals. It represents more of a political statement than a genuine leap forward in Russian military aviation.